Now watch it. We have three processes. Given that we have three processes P1, P2 and P3, and the arrival times are this, and the priority is this, and here the priority is lowest number is given highest priority and highest number is given lowest priority, right? Therefore 3 is highest lowest priority and 1 is highest priority and 2 is in the medium, right? And now the CPU times are, the burst time is like this: CPU, IO, CPU, and CPU time is 1 and IO time is 5 and CPU time is 3. Okay, and the algorithm we are using is preemptive priority. So what is it? We are going to run a process until we get a new process which is having higher priority. If we don't get any process which is having higher priority, we can run it till completion, right? So once we get a process which is having higher priority, then we are going to preempt the present one. That is the procedure, right? And here the tricky part is even the burst times are involved, which means even if you don't pull out a process because of the priority issue, the process will itself get out from the CPU and get into the blocking state because of the IO requirement. Let's see this. Now you are going to start at 0. You are going to start at 0 and you are going to start the process P1, right? And P1 is going to run for 1 unit. See, as of now there is only one process available, therefore you have to run only that process without looking even at the priority, right? And now if you take P1, it is saying that I can run only for 1 unit. So whatever you do, it is going to run only for 1 unit. Therefore you can run it for only 1 unit, and then afterwards it is going for IO, isn't it? And how long is it going for IO? It is going for IO for 5 units. From 1 plus 5 means till 6. Therefore 2, 3, 4, 5, 6. So till this point you should not consider scheduling P1 again, right? So P1 is for IO here, which means it is blocked. Therefore from here to here you should act as if P1 is not there, right? And now the time is 1. So at this time 1, no process has arrived, only one process is available and that process has gone for IO, and P2 and P3 are not available. Therefore from 1 to 2 CPU is completely idle from 1 to 2, right? And at time equal to 2 this P2 is suddenly available, and now that is the only available process. In fact P1 is not there, P3 has not yet arrived, P3 will arrive at 3, therefore there is no other option. I'll take P2 and execute it. So I am going to take P2 and execute it till 1 unit, and then I'll check. So at this point what happened is, okay, you should even keep track of what is happening to the process times. This is 0 now, not required, and this is 2 now, isn't it? And now at this point 3, the new process P3 has arrived, which is having highest priority. Therefore you are supposed to stop P2 here and schedule P3. Yes, I am going to schedule P3, and since P3 requires 2 units of time and only two processes are available, P3 is going to run till 2 units. So till this point P3 is going to run without leaving the CPU, and at this point P3 will go for IO. So how much time does it need for IO? 3 units. From 5 it requires 3 units, which means you should not consider again P3 for scheduling till from 5 plus 3, which means 8, 6, 7, 8, right? So till this point you should not again consider P3. Therefore this entire time P3 is out for IO. So now at this point, exactly at this point, if you watch it, P1 is not available as well as P3 is not available. These two are definitely not available, so we don't have any other option, isn't it? So because of no option, I have to schedule only P2 which is available. So I am going to schedule P2. Now how much time can P2 run? P2 can run for 2 units, isn't it? But then let me stop it at 6. The reason is only 1 unit. And now let me see, at this point P1 has got available. Now at this point P1 and P2 both are available, but if you look at the priority, P1 is having highest priority and it has time to run, right? Therefore at this point I am going to start P1, even though P1 is available, isn't it? See, P2 is available and P1 is available. I am going to take P1 because P1 is having the higher priority compared to P2, right? and let me run it for 1 unit, and again after running 1 unit still P3 is not available and P2 is having lower priority. I'll again run P1 for 1 more unit, isn't it? So at this point, 2 units are done and suddenly P3 became available. Now P3 became available, and how many units, what is now at this point we have P1, P2 and P3, everything is available, right? So P2 is available. See, P2 has run only for 2 units, check it. Here it has run for 1 unit and here it has run for 1 unit. Therefore, it still have 1 more unit before it could go for IO. Therefore, at this point, P1 is available, P2 is available, P3 is available. But P2 is still available at this phase and P2 and P3 are available at these phases, right? Now, which one do you want to take? So, if you observe it, all the 3 are available and the highest priority is for P3. Therefore, I am going to take P3 and I will be running it for 1 unit because it requires only 1 unit, isn't it? So if I run it for 1 unit, it is also over, right? If I run it for 1 unit, it is going to be 9. P3 is over. Now I have only 2 processes at my hand. One is P2 and other is P1. And coming to this P1 and P2, the smaller one is, the highest priority is for P1. Therefore, I could run P1 one more time, isn't it? So how much time is remaining for P1? Check this. P1 has run for initially 1 time and then P1 has run here for 2 units. Therefore only it requires 1 more unit, right? It requires only 1 more unit. So P1 I can run it for 1 more till 10 and it is going to complete. Fine. And now at this point, at time t equal to 10, at this point only one process is available, which is nothing but P2, right? And it is still available here. If you watch it, P2 has run only for 2 units, here 1 unit and here 1 unit. Therefore it still has to run for 1 unit, then go for IO and then come back for CPU. Therefore here P2 is going to run for 1 unit, which is nothing but till 11, and then it is going to go for IO, right? So how much time is it going to go for IO? And during this time there is no process, therefore CPU has to be idle. Only one process available is P2 and it is going for IO request. And so for 3 units, which means from 11 to 14, it is completely idle, right? And after that it comes back and again executes 1 unit of CPU time, which means P2 will again come back and it will run for 1 more unit. Therefore by 15 it is going to be finished, right? Now if you see this, there are some idle times, right? CPU is idle at some points. Maybe some interesting questions will be like this: what is the completion time? You can write completion time and waiting time and then turnaround time, everything as usual. Let's see this. So completion time of P1 is P1 got completed at 10 and completion time of P2 is P2 got completed at 15 and completion time of P3 is 9. And then what will be turnaround time? Turnaround time will be completion time minus arrival time. So 10 minus 0 is 10, 15 minus 2 is 13 and 9 minus 3 is 6. And then what is waiting time? Waiting time is turnaround time minus burst time. So what burst time? You have to add these 2 numbers, right? These are the burst times. So 1 plus 3 is 4, 10 minus 4 is 6 and 1 plus 3 is 4, right? And 11 minus 4 is 9 and 1 plus 2 is 3 and 6 minus 3 is 3. That is the waiting time. So here the waiting time is nothing but the total time spent by the process both in the ready queue as well as the blocking queue, right? That block state waiting for IO. Earlier it was only the time spent in the ready queue. Now here I am counting even the time spent for IO also as the waiting, right? But then the burst time is how much? Only the time taken for at the CPU. Got it? And now you can find out the response time also. You can do it. You do it, please. What is interesting question is, in this total time, what is the CPU utilization or what is the efficiency of CPU? So what is the total time? It started at 0 and it has gone till 15, right? So the total schedule is for 15. And out of this 15 units, out of this 15 units, how many units did you really use and how many units you wasted? So you wasted 1 unit here and then 3 units here, which means 4 units are wasted. Therefore, this is the inefficiency of CPU. CPU inefficiency is into 100. This is inefficiency. Then what is CPU efficiency? You have to find out 1 minus this. So which is nothing but 11 by 15, which means out of 15 units we have used successfully 11 units, right? Therefore efficiency is 11 by 15 into 100 and inefficiency is 4 by 15 into 100. Got it? So that is how we can find out efficiency and inefficiency of the CPU here, right? Fine.